Hacker News Daily, yesterday's top tech stories. Introduction. Welcome back to Hacker News Daily, where we break down the most interesting tech stories that got the community talking. I'm your host, and wow, yesterday was quite a day on Hacker News. We reviewed 26 stories, and the 5 that rose to the top really paint a fascinating picture of where technology is heading, and maybe more importantly, where we're conflicted about it going. We've got major releases shaking up the AI and video processing worlds, autonomous vehicles taking on their biggest challenge yet, heated debates about programming languages, and a government move that has people questioning the fundamentals of how America does business. So buckle up, because we're diving deep into the stories that had hundreds of developers, engineers, and tech enthusiasts furiously typing their thoughts yesterday. Let's start with the technical releases that are pushing boundaries in very different ways. Story 1. FFmpeg 8.0. Now, let's dive into something that's got the developer community absolutely buzzing. FFmpeg 8.0 just dropped, and folks, this is a big one. They're calling it Huffman, and with 743 points and 170 comments on Hacker News, it's clear this release has struck a chord. So here's what's fascinating about this release. FFmpeg is basically reinventing how video processing works under the hood. They've introduced this completely new approach using Vulkan compute shaders for encoding and decoding video. And I know what you're thinking. Oh great, another GPU thing that only works on specific hardware. But that's exactly what's not happening here. This works on any GPU that supports Vulkan 1.3, which is pretty much everything modern at this point. The paradigm shift here is really something. Instead of needing those specialized hardware decoders that are baked into your GPU, the ones that only work with certain codecs and certain resolutions, FFmpeg can now use the general compute power of your GPU. It's like, imagine if instead of needing a specific key for every lock, you had a universal lockpick that could adapt to anything. That's what they've built here. And the format support they've added is it's comprehensive. We're talking native decoders for ProRes RAW, which is huge for video professionals, VVC support, that's the versatile video coding standard that's supposed to be the successor to HEVC. They've even got Real Video 6.0, which, okay, I haven't thought about Real Video in years, but apparently someone still needs it.
What really caught my eye in the discussion threads was this interesting technical debate about how they're actually achieving speedups with traditionally sequential algorithms. One commenter, OneSalt, raised a really good point. They're asking how FFmpeg manages to parallelize something like FFv1's arithmetic coding, which is inherently sequential. It's a valid question, because you can't really decode frame 2 until you've decoded frame 1, right? The answer probably lies in parallelizing within frames rather than across them, but it shows the kind of clever engineering that went into this. The community reaction has been, well, it's been heartwarming, honestly. You've got people calling FFmpeg one of the most important pieces of software ever written, comparing it to fundamental libraries like OpenSSL and SQLite. And they're not wrong. FFmpeg is everywhere. It's in your streaming services, your video editors, your social media apps. It's the invisible backbone of modern media consumption. But here's what really resonated with me from the discussions. Multiple people mentioned how LLMs have completely changed their relationship with FFmpeg. Because, let's be honest, FFmpeg's command line interface is notoriously complex. I mean, we've all been there, spending half an hour trying to figure out the right combination of flags to do something that seems like it should be simple. Now people are just asking ChatGPT or Claude, hey, how do I convert this video to that format with these specific requirements? And boom, you get the exact command you need. One commenter put it perfectly. They said, 50% of working with FFmpeg used to be assembling these long, complex command line strings, and the other 50% was fighting with shell of faping. And yeah, that tracks. I've definitely lost hours of my life to misplaced quotes and backslashes in FFmpeg commands. What's really interesting about the Vulkan approach is that there's a catch, and FFmpeg is being transparent about this. They say only codecs specifically designed for parallelized decoding can be implemented this way. This raises some fascinating questions about the future of codec design. Are we going to see new codecs being designed from the ground up with GPU parallelization in mind? Will this influence how the next generation of video standards are developed? The practical implications are huge too. Think about it. If you can do high-quality video encoding and decoding on any modern GPU without specialized hardware, that democratizes so much of video production. Small creators, indie developers, people in regions where specialized hardware is expensive or hard to get, they all benefit from this.
And let's not overlook the cross-platform support they've added. We're talking Vulkan VP9 and AV1, Vea VVC, even Open Harmony support for H.264 and H.265. That's basically every major platform and codec combination you could want. You know what this reminds me of? It's like when software-defined radio started replacing specialized radio hardware. Instead of needing custom silicon for every protocol, you could just use general-purpose compute power and software. FFmpeg 8.0 is doing the same thing for video processing, and that's genuinely revolutionary. The fact that this is all open source, maintained by volunteers, and given away for free, it's one of those things that makes you appreciate the incredible generosity of the open source community. As one commenter noted, FFmpeg is responsible for an enormous amount of value creation in the world, probably in the trillions of dollars when you consider all the products and services built on top of it. And yet, it's just there, free for anyone to use. So yeah, FFmpeg 8.0, it's not just an incremental update. This is a fundamental rethinking of how video processing can work, and it's going to have ripple effects throughout the entire media technology stack. If you work with video in any capacity, this is definitely something you'll want to check out. Speaking of fundamental tools getting major updates, let's shift gears to the AI world, where DeepSeek is making some interesting moves. All right, now we're diving into something really interesting. DeepSeek v3.1 just dropped, and it's got the Hacker News crowd pretty fired up with over 700 points and 250 comments. And honestly, after digging into this, I can see why people are paying attention. So here's what's fascinating about this release. DeepSeek is doing something I haven't really seen before with their hybrid think and non-think modes. Imagine having one model that can basically switch personalities. You hit a button, literally called the Deep Think button, and suddenly your AI goes from giving you quick, snappy responses to actually showing its work, reasoning through problems step by step. It's like having both a quick-witted friend and a thoughtful professor in the same package. What's clever here is they're addressing this fundamental problem we've all been dealing with in AI deployments, right? You want fast responses for simple queries, but sometimes you really need that deep reasoning for complex tasks. Usually you'd have to switch between different models, manage multiple APIs, deal with different pricing tiers. It's a mess. DeepSeek is saying, nah, just use one model and toggle the mode. That's actually pretty elegant.
The technical achievement here is no joke either. They did this massive 840 billion token continued pre-training effort just to extend the context window to 128K tokens. To put that in perspective, that's like you could feed it a decent-sized novel and it would actually remember the beginning when it gets to the end. And they're claiming their new Think mode is actually faster than their previous reasoning model, while performing better on agent benchmarks. Now, the community reaction is where things get really interesting. You've got this split personality in the comments. On one hand, people are absolutely loving the pricing. We're talking $0.56 per million input tokens. That's aggressive. One commenter pointed out that's basically throwing down the gauntlet to Western AI labs. But then you've got users like xmichael909 saying, and I quote, "This thing hallucinates more than any model I've used in the past 6 months." Ouch. There's also this fascinating technical discussion happening about running it locally. Apparently, you need something like 250 gigabytes of RAM or VRAM to run this thing optimally. That's not exactly consumer hardware territory, though some brave souls are trying to run it on Apple Silicon with unified memory, which, good luck to them.
What really caught my eye, though, was this comment from RSANEQ, who did the math and pointed out that despite the attractive sticker price, DeepSeek v3.1 is actually running 10 times slower and costing 3 times more than some alternatives when you factor in performance. It's a good reminder that raw pricing isn't everything. You've got to look at tokens per second, latency, all that stuff. The behavioral quirks people are reporting are kind of amusing too. Apparently, it has this habit of being excessively verbose, using repetitive phrases. Someone mentioned it keeps saying things like, "let me help you with that," over and over. It's like that overeager intern who just won't stop talking. But here's what I think is the bigger picture. DeepSeek is playing a really interesting game here. They're open sourcing these massive models while simultaneously offering competitive API pricing, and they've locked in their prices until September 2025. That's a direct challenge to the business model of companies like OpenAI and Anthropic. They're basically saying, we'll give away the recipe and sell you the cake cheaper than anyone else. The compatibility with Anthropic's API format is also a smart move. It means developers can basically drop this in as a replacement without rewriting their code. That's how you gain market share quickly.
Look, is this going to dethrone GPT-4 or Claude? The benchmarks suggest probably not. Users are reporting it's definitely behind the top-tier models in raw capability. But at these prices, with this flexibility and being open weight, it doesn't need to be the best to be disruptive. Sometimes being good enough at a fraction of the cost is exactly what the market needs. Now, while we're talking about tools that developers have strong opinions about, we need to address the elephant in the room, or should I say, the gopher in the room. Story 3. Go is still not good. Now, speaking of things that get developers fired up, our next story is Go is still not good. And wow, did this one strike a nerve on Hacker News. We're talking 531 points and over 700 comments, which tells you right away that we've hit on something the community has strong feelings about. So here's the thing. This article isn't just some random drive-by critique of Go. The author has been at this for over a decade, with previous posts like Why Go is Not My Favorite Language going back years. And their main beef? It's that Go deliberately chose to ignore decades of programming language wisdom, particularly around error handling and variable scoping. Let me break down what's got everyone so riled up. The author's primary complaint is about how Go forces you to handle errors in a way that, well, it's like being forced to leave your tools scattered all over your workshop instead of putting them away when you're done with them. When you're dealing with functions that return multiple values, which is super common in Go, you can't limit your error variable to just the scope where you're checking it. Instead, that error variable has to live throughout your entire function. Here's why that matters. Imagine you're reading through code trying to find a bug. You see an error variable being reused across multiple, completely unrelated operations. Your brain immediately goes, wait, hold up. Is there some hidden dependency here? Is this error somehow connected to something earlier? And often the answer is no. It's just Go forcing you to reuse variables because of how it handles scoping. The author argues this makes code harder to understand and can introduce really subtle bugs. And then there's the infamous if error not equal nil return error pattern that Go developers type probably 100 times a day. It's become such a meme in the Go community that people joke about it constantly, but the frustration is real. This verbose error handling creates situations where you're constantly juggling these error variables that stick around way longer than they should. What's fascinating about the discussion thread is that it's not just people piling on to bash Go. Actually, most of the commenters have this really nuanced take. They're like, yeah, these problems are absolutely real and frustrating, but... And then they go on to explain why they still use Go anyway. It's this interesting love-hate relationship. One commenter mentioned their company literally rejected adopting Go specifically because of how it handles nil values. And, oh boy, the nil thing. Go has this problem where there are actually 2 types of nil, which sounds like a computer science joke, but it's not. You can have a nil interface that's not actually nil, which is exactly as confusing as it sounds. Multiple developers in the thread called this out as a genuine source of bugs in production systems. The memory management stuff that came up in the discussion is particularly interesting for anyone working on resource-constrained systems. Developers are talking about fighting against Go's garbage collector, dealing with heap fragmentation, discovering hidden allocations. One person described it as constantly battling the language to get the performance they need. That's not exactly a ringing endorsement. But here's where it gets really interesting. There's this counter-narrative in the thread where some developers are saying, look, these criticisms are technically correct, but ultimately pedantic. They argue that Go's practical benefits, the fast compilation, the excellent tooling, the straightforward deployment story, these things matter more in the real world than perfect language design. One commenter made a point that really stuck with me. They suggested the real problem isn't Go's design choices, but that developers come to Go expecting high-level abstractions when Go is intentionally exposing more bare metal concerns. It's like Go is trying to be a systems language that's easier to use than C, but people expect it to be as abstracted as Python or Ruby. There's also this whole thing about defer statements that I hadn't really thought about before. Apparently, defer works at function scope rather than lexical scope, which means if you're processing resources in a loop and using defer to clean them up, surprise, they all get cleaned up at the end of the function, not at the end of each loop iteration. That's the kind of gotcha that can cause real problems in production. The author makes this provocative claim that really captures the frustration. They say the world knew better, and yet Go was created the way it was. It's suggesting that Go's creators looked at decades of programming language evolution, saw all these solved problems, and said, nah, we're going to do it the old way anyway.
You know what's telling, though? Despite all these criticisms, Go is still hugely popular and growing. Companies are still adopting it, developers are still learning it, and major projects are still being built with it. Which raises the question, are these design flaws actually that important? Or is there something about Go's overall package that makes these irritations worth tolerating? The thread really captures this tension in the developer community. We want our tools to be theoretically sound and practically useful. And when those two things conflict, well, that's when you get 700 comment threads on Hacker News. Speaking of technology that has to work in the real world despite its challenges, let's talk about what happens when you take autonomous vehicles and drop them into the chaos of New York City. Story 4, Waymo in NYC. Next up, we're diving into a story that's got the Hacker News community buzzing. Waymo has just been granted its first permit to begin testing autonomous vehicles in New York City. And honestly, this feels like watching someone decide to learn swimming by jumping straight into the deep end of the pool with sharks in it. So here's the deal. Alphabet's Waymo is bringing up to 8 of their self-driving vehicles to Manhattan and downtown Brooklyn, and they'll be testing through late September. Now, if you've ever driven in New York City, you know this is basically the final boss level of urban driving. We're talking about a place where taxi drivers treat red lights as suggestions, pedestrians play real-life Frogger, and double parking is practically an art form. What's really interesting here is the regulatory twist. While Waymo's cars are cruising around San Francisco and Phoenix completely driverless, no human, no steering wheel, just pure robot confidence, New York state law requires them to keep a human safety driver behind the wheel at all times. It's like, we trust you, but also we absolutely don't trust you yet. The thread really captures this tension in the developer community. We want our tools to be theoretically sound and practically useful. And when those two things conflict, well, that's when you get 700 comment threads on Hacker News. But here's where it gets really interesting. There's this paradox that keeps coming up in the comments. Waymo vehicles are sometimes too polite for their own good. Multiple users are sharing stories about how these cars get bullied by aggressive human drivers precisely because they're so law-abiding. Imagine a robot car trying to make a left turn in Manhattan while every other driver is playing chicken with the yellow light. The Waymo just sits there, patiently waiting for a safe opportunity that might never come. One commenter from San Francisco mentioned they've seen Waymo cars get stuck because pedestrians realize the car will always stop for them, so they just casually stroll in front of it knowing there's zero risk.
It's like we're teaching the robots our worst behaviors by exploiting their best ones. There's also this really thought-provoking thread about whether we should even be celebrating more cars, autonomous or not, in Manhattan. Some folks are arguing that instead of making cars smarter, we should be making cities more walkable and investing in public transit. One person shared this gut punch of an observation about riding in a climate-controlled autonomous vehicle past homeless encampments in San Francisco. Talk about the future being unevenly distributed. The technical challenges here are mind-blowing when you think about it. NYC isn't just traffic. It's construction zones that pop up overnight. It's delivery trucks creating temporary one-lane streets. It's cyclists who treat traffic laws as performance art. Several engineers in the comments are speculating about how Waymo's algorithms will need to adapt. Will they need a special NYC mode that's more aggressive? Can you program a computer to honk preemptively? What strikes me most about this whole situation is that New York might actually be the perfect testing ground precisely because it's so chaotic. If Waymo can make it there, well, you know the song. The fact that they're starting with just 8 vehicles with safety drivers shows they're not exactly charging in blindly. They're dipping their toes in the water before diving into the deep end. And you know what's wild? Several commenters who live in NYC are actually excited about this, saying anything would be better than the current state of human drivers. One person joked that Waymo cars can't possibly be worse than New Jersey drivers coming through the tunnel, which, harsh but probably fair. The bigger picture here is about more than just robot cars navigating around hot dog carts. This is about the future of urban transportation, about whether American cities can leapfrog ahead in autonomous vehicle adoption, and about how we balance innovation with safety. Some commenters are pointing out that while the US debates and regulates, China is already deploying massive autonomous vehicle fleets. It's that classic tension between moving fast and not, literally breaking things or people. Now, speaking of government involvement in technology companies, our final story takes this to a whole new level. All right, so our next story is absolutely fascinating and honestly a bit shocking. The US government just took a 10% stake in Intel. Yeah, you heard that right. The federal government now owns a tenth of one of America's most important semiconductor companies. And the way they did it is, well, let's just say it's raising a lot of eyebrows. So here's what happened. The government essentially converted $8.9 billion worth of promised funding into equity. They're getting 433.3 million shares at $20.47 per share. But here's the kicker. They didn't actually pay anything for these shares. About $5.7 billion of this comes from CHIPS Act grants that hadn't been paid out yet, and another $3.2 billion from separate government awards for secure chip programs. They basically said, hey, Intel, instead of giving you this money we promised, we're just going to take shares instead. And since Intel stock is trading around $25 to $26, the government's already sitting on something like an $11 billion valuation. That's an instant paper gain of over $2 billion. The Hacker News community is, well, they're not happy about this. With 529 comments and counting, the discussion is getting pretty heated. A lot of folks are seeing this as a massive departure from how America typically does business. One commenter put it pretty bluntly. They called it the end of the rule of law and compared it to something you'd see in Venezuela or North Korea. And honestly, when you think about it, there's this wild irony here. The Trump administration, which has been so critical of China's state-controlled economy, is essentially adopting their playbook by taking direct government stakes in strategic companies. What's really concerning people is how this went down. From what we're hearing, this wasn't exactly a voluntary transaction. The narrative seems to be that Intel was essentially told, accept this deal or else. And that or else is doing a lot of heavy lifting here. We're talking about retroactively changing the terms of already approved funding, turning grants into equity stakes. That's not how contracts usually work, right? But here's where it gets even more interesting. The government also got a warrant that could let them acquire another 5% of Intel if the company no longer maintains majority ownership of its foundry business. So they're not just taking a stake, they're positioning themselves to potentially increase their control if Intel's structure changes. Now, to be fair, there were a few voices in the discussion saying, hold on, maybe this isn't entirely crazy. Some folks pointed out that if the government's going to bail out companies or provide massive subsidies, maybe taking an equity stake isn't the worst idea. At least then, taxpayers get something back if the company does well, right? It's the whole socialize the losses, privatize the gains problem turned on its head. But the overwhelming sentiment is that this crosses a line. People are worried about what precedent this sets. If the government can retroactively demand equity for grants that were already approved and budgeted, what's next? One commenter made an interesting point. They said this feels less like strategic industrial policy and more like the government discovering it can just take stuff. And once that door's open, it's really hard to close. The technical and strategic implications here are huge too. Intel's been struggling to compete with TSMC in advanced chip manufacturing, and now they've got the US government as a major shareholder. On one hand, that could mean more support and resources. On the other hand, government ownership doesn't exactly have a stellar track record when it comes to innovation and competitiveness in the tech sector. What really strikes me about this whole situation is how it represents this broader shift we're seeing in how governments think about strategic industries. Semiconductors aren't just another business anymore. They're national security assets. And apparently, that means the old rules about government intervention in private markets, those might not apply anymore. The question is, where does this end? If Intel today, who's tomorrow? And what happens when other countries start doing the same thing with their strategic companies? The discussion on Hacker News really captured something important. This uncomfortable feeling that we're watching the playbook change in real time and nobody's quite sure what the new rules are going to be.
What strikes me about these stories is how they all touch on this fundamental tension in technology today. We're pushing boundaries technically while grappling with what those advances mean for society, for business, for the very nature of how we build and govern technology. Whether it's robots navigating human chaos in NYC or governments taking equity stakes in tech companies, we're clearly in uncharted territory. These were the 5 stories that rose to the top from 26 that appeared on Hacker News yesterday, generating over 2,700 points and nearly 2,700 comments combined. The conversations happening in these threads aren't just technical debates, they're about the future we're building, one commit, one policy, one autonomous mile at a time. Thanks for joining me for today's deep dive into what's got the tech community talking. Keep building, keep questioning, and we'll see you next time on Hacker News Daily.